track has two straight sides, each of length 40 metres. Each end of the track is a semicircle of radius 27 metres. The diameter of each wheel of Ian's bike is 599 millimetres. Ian is going to ride his bike around the track once. Calculate how many complete revolutions each wheel of his bike will make. So, first of all, the thing I notice is that his wheel is different units to the rest of the measurements. So perhaps we'll change that one first of all. So we need to think, okay, so 10 millimetres equals 1 centimetre. So, and then 100 centimetres equals 1 metre. So I need to divide it by 10 first of all to get to centimetres, then by 100 to get it to being in metres. So 590 divided by 10, so it is really 59 centimetres, so divide that by 100, so it's really 0.59 metres. Now I'm going to be working at least in the same units. So if he's going right the way around, I need to think about what distance is he travelling around. So I know it's going to be 40, and there's going to be the 40 from this side. And then I need to think about this curve length here and this curve length here. If I push that together, I will have a complete circle. So I need to work out the circumference of my circle. So to work out my circumference, either that 2 pi r, or some of you might think of it as pi times diameter. I'm being given my radius, so I'm going to do the 2 pi 27. So we multiply those together. So 2 times by pi times by 27 equals 54 pi. Okay. So now I need to add the two other sides on, so now I need to add 40 and add 40, or add 80 together. So I'm going to add the 40, add the other 40, and that gives me an answer of, and obviously it's calculator paper, 249.6460033. So that's the whole distance around, so that's taken of 249 odd metres. So now I need to figure out how many times his wheel will turn. So now I've got to be careful because the diameter of each wheel of Ian's bike is 590. So I think his diameter of his wheel is 0.59 or 590. So again, I need to use that 2d probably this time because I've already got my diameter to work out how far around is our wheel. So 2, be careful, pi d, not 2d, pi d. So shift and then pi times by my diameter of 0.59 equals, so the distance around his wheel is going to be 1.85353,966. So I've got these two solutions. Okay. So now I need to do how many of these will go into this. So I need to do my 249.6460033 divided by my 1.85 around his wheel, because that's the metres around his wheel. So 249.6460033 divided by the distance around his wheel gives me an answer of 134. So I'll make sure I show the calculation I'm doing, so make sure you guys can see it as well. So I've done my 249.646 divided by 1.853. So that gives me a solution of 134.686. So calculate how many complete revolutions each wheel of his bike will make. So how many complete revolutions? So it's going to be 134 complete revolutions with a little bit. So it's 134 revolutions. So now here, so a couple of very similar questions for you to attempt. Press pause and have a go at these. Pause. So, if we have a look at this first one. The diagram shows a cycle track. The track has two straight sides, each of 50 metres, and this end radius of 27 metres. So now my distance is slightly different. Okay, so it's a very similar question. And again, This time my diameter of the wheel is 595 millimeters. So remember, I need to convert that. So remember, 1 centimeter is 10 millimeters, and 1 meter is 100 centimeters. So first of all, I need to do that 595, divide it by 10, which gives me that 59.5, and then do my 59.5 divided by 100, which gives us 0.595 meters. This is diameter. So what I'm going to go for and working out is, first of all, I've got the distance along here, which is 50. I've got this distance here, which is 50. And I've got the 2 semicircles, which make up the full circle. So what I'm going to go for and working out first of all is the circumference of my circle. So that 2 pi r. So 2 times by pi times by my radius, which is 27. Okay, so that would give me my value of 2 times by pi times by 27, give me 54 pi. Then I've got to add on my 250, so that's going to give me 54 pi plus the 100. So that's my distance all the way around. Okay. Now I need to figure out the distance around his wheel. So remember, his wheel, the diameter is 0.59. If I do pi times diameter, that'll give me the distance around his wheel. So shift and then pi times by my diameter, 0.595, would equal 1.8692, and the other values. So now I need to do this distance divided by this one here. So my 54 pi plus the 100 divided by the distance around the wheel, 1.8692, would equal, so that equals 144.253. So how many complete revolutions? It's just 144 complete revolutions around. So here is the final question for you to have a go at. Okay. So very similar. Again, I've got my 50 up here. I've got, this time my radius is 17, okay, and the diameter of the wheel is 580. So again, we want to turn that diameter into meters. So 1 centimeter, remember, is 10 millimeters. 100 centimeters equals the 1 meter. So going through a very similar process again. So I'm going to do my 2 pi r to work out the circle. So this time it's going to be 2 times by pi times by 17. So that will be 34 pi. This time I'm going to keep it in terms of pi until the very end. Right? So then I've got to add my 250s on. So I've got 34 pi plus the 100 is the full distance right the way around. Then I need to work out the circumference of the wheel. So the diameter is 0.58 because the whole process would have gone through up here. So I'm going to have pi times by 0.58. So it's the value of this, okay, the value of this are the two key ones. So I'd end up doing that 34 pi plus 100 divided by pi times by 0.58. So I'm going to use my fraction button. 34 pi plus 100 divided by pi times by 0.58 equals, so that would give me a value of 113.501. Question is how many complete revolutions? It's 113 complete revolutions.